Hello everyone, and today I'm at ST Microelectronics campus in Greater Noida, and I'm super excited because I'm here for the annual STEM Fest 2026. Actually, this is the first time I'm going to visit this event, and honestly, I can't wait to see what the students have created. From what I've been told, more than 70 students from grade 3 and all the way up to grade 12 have spent the last couple of months working on these STEM projects. And today, they're finally showcasing them through the live demonstration. So let's see what's inside and check it all out. Wow, look at the crowd and energy here. Let's speak with someone from ST team who can tell us more about this wonderful initiative. How did this entire initiative started, and what's the vision behind the annual STEM program, and what kind of impact is it making on the students? So let's talk to someone.
Good morning. I am Manoj Kumar, and I'm very pleased to welcome you to the fifth STEM Family Day that we are having it in ST campus right in this place since 2021. When we started in 2020, it was the ideation session. What do we do? There was a phase of the discovery. We discovered with the teachers, we discovered with the students, we discovered with the global ST to understand what could be most relevant for ST. In the other places, it is like more like, let's say, involving the girl child. For us, it was to involve girl child, but not only the people from the good economic background and the people from the left out background as well. We are having this program for all of this. We are having several programs running in ST India ever since by the volunteers, by ST employees. We are having the events like Break the Bias, where we go to several schools. We are having workshops for the teachers. We are training the teachers over here around the ST platforms. Typically, we call them STM32, which is a very nice thing. In fact, we have reached a stage that our students from 3 to 5 who are learning the basic electronics, then 6 to 8 who are working on the robotics, and then 9 to 12 who are working on the IoT, AIML, and so on. Then we collaborated with all the running initiative of ST India, including UniConnect, including ST Foundation. What we added in last 2 years is what we call as Tech Blazers. So Tech Blazers is a program for the students who are already into engineering, no matter whether it is civil, mechanical, electrical, computer, or whatever, and no matter whether it is first year or final year, we allow them, we give them an exposure on the live projects, which we call through the ST Fab Lab. In India, the Fab Lab that we have is called the Proto Lab. So all these students, in fact, 30 of them worked on the live projects for 8 to 10 weeks. It is their summer time and they are here in our ST campus. All in all, we have an environment of learning. It gives possibility for ST's employees to be engaged with the ecosystem, to be engaged with the schools, to be engaged with the teachers, and really it is fantastic, it is phenomenal, and really it's one of the rare achievements for a company like ST that we are having this kind of learning environment involving the schools, involving the kids, involving the management, involving every stakeholder. Thank you.
And now, finally, the most exciting part. It's time to meet the real stars of today's event, and yeah, of course, the students. So let's go around and talk to students and check out some of most exciting innovations they have created. I'm sure we're going to discover some really interesting concepts. So let's get started.
Our team's name is Visual Magicians, and the theme of our project is the visual magic through strobe effects. The components of our project are: first, strobe IC, variable resistor, vitality, two battery modules, two switches, one slide switch and one press switch, two resistors, one of 100 ohms and one of 5.1 k ohms, and PN transistor, motor with illusion discs, metal wires and jumper wires. When flickering light falls on moving disc, different illusion patterns are formed due to strobe effects. These patterns can be changed by the flickering frequency of the light. With Switch on the switch. The battery gives power to the variable resistor and the strobe IC. Strobe IC gives power to the flickering LED light.
Very, very good, Adi. The slide switch is on. When we press the press switch, the motor gets on, and we can see the different designs on the disc because of the flickering light. We can change the flickering light speed using variable resistor and see different designs and patterns and
Our
shapes.
project, the Goalpost. Our group's name is Mastermind and the project's name is Golden Goals. In this project, all you need to do is score a goal. We use Vita Science and the board WB55RG.
The aim of this project is to simulate a penalty kick where the player will shoot and try to score the goal. This project uses basic concepts of input, output, and decision making.
Through this project, I learned how robotics and programming can be used in interactive games. It made both fun and practical.
Let us demonstrate how this works. You can place the robot any way you want. The ball will stay at its own position and you need to try to make the goal.
Good morning, everyone. We are Team Flying Coders, and this is our project that is Still to Fly, which is a digital aircraft tilt simulator.
So we have used different components. We have used the Nucleo L476RG board and the accelerometer to detect the tilt. So the accelerometer sends the data to the microcontroller of the board, which processes the data and sends it to the computer. We have used Python programming to make the GUI. So using the data, it tilts the plane accordingly.
So, like its applications include like the airplane simulation in which it understands the tilt and like it basically processes the tilt and learns to balance it, and it can also use in the airplane simulation for the training pilots to learn the tilt and balance it.
My name is Vihan. My name is Vidhan. My name is Ayansh.
And my name is Vivan.
Fluorescence 22 is a smart plant monitoring system designed to help people take better care of their plants. To grow properly, plants need the correct temperature, correct light, and correct water. But sometimes the people forget to check these conditions, which can hamper a plant's growth. So this project solves this problem by continuously monitoring the plant's environment and alerting the user whenever the conditions are unsuitable. Our project uses an STM32 Nucleo L47RG microcontrollers along with several sensors. We use a temperature sensor to check the surrounding temperature, a light sensor to see the light around it, a soil moisture sensor to detect the amount of water in the soil, and an LCD screen that shows the readings in all time. Wherever any condition does not match, fluorescence 32 would alert the user. For example, if the soil is too dry, or the temperature is too high, or the plant receives too much or too little light, the system will notify the user so the correct action can be taken quickly.
Fluorescence 32 help maintain healthier plants by providing continuous rather than timely alerts. It reduces the chance of overwatering, underwatering, or exposing plants in unsuitable environmental conditions. This project demonstrates how sensors and automations can be used in everyday life to support plant care. Thank you, we hope you enjoyed learning about fluorescence 32.
Actually, this project we have created from the sustainable point of view. because we want to save the water as well. And as part of this project, we want to have a as extension of this project, like to have an automatic water planting system. So whenever there's a need of water for the plant, we should have an automatic system, the provisioning of the water actually. So they would like to take it further to as a part of the extension of project next year as well. So this is the prototype what they have done actually. Thank you.
Hi, my name is Mishi. We have made a duality robot which is having two modes, entertainment and maintenance. In entertainment mode, we have a math quiz, how far to go. And in the maintenance mode, we have a temperature sensor which senses the temperature of the current environment.
My name is Rachit and I like to continue on the topic of maintenance mode. In the maintenance mode, it sees the current temperature of the environment and updates it on the LCD screen. When the temperature is high, it's going to display text cold, and when it is less, then it will display text hot. When the temperature is cold, then it will turn on the game how far to go. I like Sanvi to continue. So in the entertainment mode, the robot will ask you some random math questions of division, multiplication, addition or subtraction. For example, your answer is 50. You have to go 50 centimeters behind, and if you are wrong or correct, it will display it on the LCD screen.
Now let's start with the working of the project. When switch S1 is turned on, the circuit gets power from the battery pack. The microphone X1 picks up sound and converts your voice, that is a mechanical signal, into a small electrical signal. This signal goes to the color organ U22, which controls the RGB LED, and as your voice gets louder, the LED changes its color. Like when we will speak in the project, the LED will change color. Like hello, it changed color. When you will speak, it will change color in the microphone. We can use this also. This is fiber optic and this is color changing egg. Hello, this looks more beautiful. Now Amanda will tell you about some more components. Hello everyone, this is a flashlight circuit. It has switch, battery, register, microphone, color organ and some LED attachments. I am going to talk about switch and register. Initially the switch is off. Current doesn't flow. When the switch is on, the circuit gets complete.
I have had really great time exploring the annual STEM Fest and seeing these young innovators presenting their ideas with so much passion, honesty, and confidence. A big thumbs up to ST Microelectronics' entire team for creating a platform like this, where students not only learn STEM concepts but also get the confidence to innovate, experiment, and present their work among all of us.